Networks are frequently classified according to the geographical boundaries spanned by the network itself. LAN, WAN, and MAN are the basic types of classification. Local area network, a network that connects computer and devices in a limited geographical area. A LAN covers a relatively small area such as a classroom, school, internet cafe, or a single building. LANs are inexpensive to install. There are two types of local area network. First is the personal area network, a computer network used for communication among computer and different information technological devices close to one person. The second is a household area network. A household area network is a residential LAN which is used for communication between digital devices typically deployed in the home, usually a small number of personal computers and accessories such as printers and mobile computing devices. The advantages of LAN are easy to share devices, easy to share data, and cost of LAN setup is low. The disadvantages are power. A good LAN is required to be on all the time. Security. Each computer and device become another point of entry for undesirable. Metropolitan area network is a high-speed network that connects local area networks in a metropolitan area. A MAN spans the distance of a typical metropolitan city. MAN uses high-speed connections such as fiber optics to achieve higher speeds. Advantages are efficiency and shared access, and all the computer-owning residents of the area have equal ability to go online. Wide area network. A network that covers a large geographic area such as a city, country, or the world. Using communication channels that combines many types of media such as telephone lines, cables, and radio waves. The internet, for example, is a type of one and the world's largest one. Hubs operate very much the same way as a repeater. They amplify and propagate signals received out all ports with the exception of the port from which the data arrive. For example, if system 125 wanted to print on the printer 128, the message would be sent to all systems on segment 1, as well as across the hub to all systems on segment 2. System 128 would see the message is intended for it and would process it. The hub doesn't bother figuring out who is supposed to receive the data. It just spams everyone. Devices on the network are constantly listening for data. When devices sends a frame of information that is addressed for it, then it will accept the information into memory found on the network interface card and begin processing the data. In fairly small networks, hubs work well. However, in large networks, the limitations of hubs creates problems for network managers. If the application files being used on this network are large and there are more nodes on the network, contention for bandwidth will slow the responsiveness of the network down. Bridges improve network throughput and operate at a more intelligent level than do hubs. A bridge is considered to be a store and forward device that uses unique hardware addresses to filter traffic that would otherwise travel from one segment to another. The bridge divides this Ethernet LAN into two segments, each connecting to a hub and then to a bridge port. Stations 123 to 125 are on segment 1 and stations 126 to 128 are on segment 2. When station 124 transmits to station 125, the frame goes into the hub, who repeats it and sends it out all connected ports and then onto the bridge. The bridge will not forward the frame because it recognizes that stations 124 and 125 are on the same segment. Only traffic between segments passes through the bridge. In this example, a data frame from station 123, 124, or 125 to any station on segment 2 would be forwarded. And so would a message from any station on segment 2 to stations on segment 1. When one station transmits, all other stations must wait until the line is silent again before transmitting. In Ethernet, only one station can transmit at a time or data frames will collide with each other, corrupting the data in both frames. The switch keeps a list where every host can be reached. It sends every packets straight to its destination without spamming the entire network, unlike the hub do. In each network card has unique address the switches can use to identify a computer. They are called MAC addresses. If computer A has a MAC address of 6 times AA, then the switch will know that the computer with that MAC address can be found on port 1. The same way with computer F. Let's see how it works in practice. We always start with empty address table since the switch has to learn where everything is. We will send a packet from computer A to computer B. At this point, the switch doesn't know where computer B is, so it will behave like a hub and flood everything. But it's learning. By checking the MAC address of the packet sending field, it learns that computer A can be found on port 1, and it will store this information in the MAC address table. Now, when you send a packet from computer B to computer A, it will no longer flood the entire network because it already knows where computer A is and it will only send a packet to port 1. The switch now knows where computer B is and adds it to the MAC address table. Reporting metrics can include load on the link between devices, delay, bandwidth, and reliability, or even hop count. In essence, Router will do all that bridges and switches will do, plus more. Routers have the capability of looking deeper into the data frame and applying network services based on the destination IP address. Destination and source IP addresses are a part of the network header added to a packet encapsulation at the network layer. Once you send the packets to your internet provider, routers make sure that your packets are passed on from network to network so that it will eventually reach its destination. Your own home router forms as a bridge to your private home network and the network of your internet provider. Through the network of your internet provider, you can reach the rest of your internet.